two circles with centers X and Y. These are two circles. They have centers. Their centers is labeled X and Y, and then they intersect. They intersect at points P and Q. If the radii of these circles is 20 cm and 15 cm, and that point of intersection is measured to be 24 cm. Okay, find the distance between the centers. Okay, so if you understand this statement, you will see with me that the diagram that will clearly represent this information will look like this. Let's see. It will look like this. Now remember, before I do this, that one of these circles is bigger than the other, because this one is 20 cm and this one is 15 cm. I need you to take that into cognizance. Okay, so obviously we are going to have a small circle. Let me have it this way: a small circle. Check out this space, this space, this space, this space. Okay. Let's shift it a little bit. Okay, and then let's assume this is the smaller one. Let me stretch this thing a little bit further. Check out the point of intersection. Okay. So let's stretch out and have this one to be the bigger circle. This is quite big. Okay, it's quite big. Let me tidy it up. Just a minute. Okay, tidy this one up as well. Just a minute. Exercise patience with me. Okay, let's assume that this is the two circles we are putting into consideration. Let me say somewhere here is the center of this one, and this is the center of this one. I'm sure we're able to see that length as well. So these two centers, we are going to label them X and Y. Okay, we are labeling them X and Y. And what was brought to our understanding is that these two circles intersect at points P and Q. So let me label here P and here Q. I'm sure that is taken. The next statement is that the radii of the circles is 20 cm. Of course, this one we take 20 cm because it's bigger, and this one we take 15 cm. Now, take note, they say that PQ is 24 cm. So let me join PQ. So they say that this is 24 cm. Okay, there is something I want you to understand, and that thing is that this is a chord. Do you understand that this is a chord? Do you see? Did you just look carefully? Did you see a part of this circle cut out by PQ? Look at it. Like if I am to shade it, I will shade it like this. It's a part of this PQ. So this is a chord. we have done a lot of explanation about issues that has to do with chord in the previous classes. So this is a chord. Now, this chord as well has a portion of this big circle here. Look at it here. Look at it here. So that's why this is a chord. This is a chord. Now, there is a theorem, a chord theorem, that says any line drawn from the center of the circle perpendicular to a chord bisects that chord and is at right angle to it. So that is to say that if I join here and here, that this line will bisect this chord PQ, and the same thing happens this way. So I am sure you will understand it when I do that joining. Okay, so let me do it. All right, this is the joining. Now another thing, this radius 20 cm and this radius 15 cm. Now I am passionate about explaining for people to understand. Are you aware that I can put this line now? If I put this line, is this not a radius? It's a radius. I can put 20 cm here. It's a radius. But what connection does it have here? Can it help me to do any calculation that has to do with x, y? If they ask me to find the distance between their centers, this thing I position this way cannot help me do that. So now watch if I put it like this, still joining the center and the circumference. Did you notice anything now? Yeah, this is circumference, this is center, and I can put 20 cm here and remove this one. Yeah, I think it did make sense now. So what again? Let me do the same thing for 15 cm. Wow, are you seeing something reasonable? Yeah, I'm thinking we are making some sense now. 15 cm. Now you know that from here to here, that this line is at right angle to this chord. Yes, by that theorem I gave. Okay, and this is also at right angle to this chord. Okay, let me label here. Let me label here N. Let me label it N. Okay, let me label it N. Now they told us that PQ is 24 cm. That means I can call here 12 cm, here 12 cm. I'm sure you clearly saw that. Now, can it be possible for us to make an extraction? Can it be possible for us to make an extraction? That extraction is that this part, I can extract it like this. I can extract it like this. I can extract it like this. And this is N. Okay, this is X. This is 15 cm. This is 12 cm. And this is Q. Because those two centers they ask us to find is X, N, and Y. Do we get that? X, N, and Y. Let me also extract that of look at this now. Okay, okay, okay. This is 20 cm. This is Y, and this is okay X, not X, N, 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 and this is Q. This is Q. Okay, so if we have been able to extract these informations, so this is 12 cm there. So I am obviously, you can see clearly with me that if I call here A and call here B, that the two centers they are asking me to find X, Y, which they are asking me what is the distance between their centers. The centers of these two circles will be equal to A plus B. Do you get that? So it will be the addition of this A and the B, which I have been able to describe here. All right. So can we now move on into calculation and see how we can be able to get those two things? I will now say from triangle XNQ, from triangle XNQ, okay, I will say A squared plus 12 squared is equals to the hypotenuse squared, which is 15 squared, by Pythagoras theorem. I'm sure we are conversant with that. Okay, so we can now have A squared plus 144 is equals to 225. That's 15 times 15. So we have A squared is equals to 225 minus 144. Okay, A squared is equals to 225 minus 144. Let me check my figures here. 225 minus 144, that will give us 81. 81, okay, by my figure I have here. So we will now have A is equals to square root of 81. I think A should be 9. The square root of 81 is 9. It then means that xn, which is equals to A, is equals to 9 cm. We keep that, okay? We keep it. And then we come back again and say from triangle Q and Y, okay? We can also say that B squared plus 12 squared is equals to 20 squared. That's by Pythagoras theorem. All right, we say B squared is equals to 144. Sometimes when you are fast, you might be making some mistakes. So B squared is B squared plus 144 is equals to 400. That's 20 times 20. Okay, so we have B squared is equals to 400 minus 144. So B squared is equals to, I just trust God I'm not running too fast. But just take your time and understand whatever I am doing here. You can watch it over and over again. We are trying to make sure that we don't exhaust excess time. Okay, 400 minus, where do I have that figure? 400 minus 144 will give me 256. 256. So if I take the square root, I will say B is equals to square root of 256, and B is equals to square root of 256 is 16 cm. So therefore we cannot make our conclusion. We cannot make our conclusion. By our conclusion, xy, which I have done some part of it here. Therefore, we can say xy, which is equals to A plus B, will be equals to my A is 9 plus 16, and that will give me what? 25 cm. This is the distance between these two circles. This is the distance. When I did this example in class, my student was like, this diagram you position down, can you position it up and use up here? And I say, yes, you can do that. It shows that you're thinking. Yes, because if you are not thinking in mathematics, I wonder what you are doing. It's not story. So you have to think and reason so that you can be able to, come up with something that will give you a way out of the mathematical problem you are facing. So I'm trusting God that this explanation to this, with both the diagram, presentation, of course, in exam situation, this diagram has marks. It will attract, conveying this information this way and being able to present a better way of explaining it and all that down to the result. I think all couple, made a lot of sense. Okay, so please, we have done a lot of classes before now, and we still have a lot of classes, hereafter to do, because after now we are going to be going over to um, circle theorems. We are going to look at all the circle theorems: angle at the center, twice angle in the circumference, angle in the semicircle, angles in the same segments, and then external angle of a cyclic quadrilateral, opposite angle of a cyclic quadrilateral, and all those theorems between a tangent and a chord is equal to angle in the alternate segment. All these theorems you are going to be looking at them one after the other. Please, you have to, when you subscribe to the channel, you'll be able to access all these classes. We have over 100 and plus classes already in our channel. So please, if you subscribe, you have access to these classes in various mathematics topics. Share it to someone out there and help your friends out there. So by so doing, you're also encouraging us to grow. I'm trusting God that you desire that we grow. So please, as you do that, God will bless you. Thank you so much for being there.